So the film Koyaanisqatsi, for those of you who weren't here, is it's a phantasmagoric poem of the screen, which in its unique way kind of demonstrates a lot of sort of both geological processes on Earth and man-made processes, which may or may not always be linked together, may or may not always be changing the climate. This is a 40-year-old movie, so there was a little bit less awareness than we have currently. But it is a film that, in its own poetic kind of way, hammers home a number of points, literally with there's only one word in the whole film, which is Koyaanisqatsi, a Hopi Indian word meaning life out of balance, more or less. So we wanted to make this will not be a poetic phantasmagoria. This will be, we'll go into some hard science here. And also because of the work that you do, you're also a popular science popularizer in a lot of ways by getting out there and educating the public, not just in classrooms. You are a science educator at large in the world, and tell us a little bit about what you do along those lines.
Yeah, sure, thanks. Outside of my research and my teaching at the university level, undergrads, graduate students, also partway through my time at UT, just became really aware of just how important science education was beyond the university. At the K-12 levels, in the general public, if we're really going to solve a lot of these problems, people have to, not everyone needs to become a scientist, but everyone should be science literate. So then we're going into the voting booth or making other decisions in our everyday lives that they have a feel for, how can we tell the truth from not the truth, say through replication, the scientific method, peer review, all the importance of all of that. And so I tried to figure out a way back when to engage the public more in what we do. We have out of the 3,000 professors at the University of Texas, I figured there's probably a handful of really good ones in terms of being able to communicate, be dynamic speakers, and are doing leading edge research. And how can we bring that to the public in a way that would capture people's imagination? And so I work with, first I find speakers who are really good, and then we work with them to make their presentation even more accessible. And we have 3 events every semester on a Friday night. This whole thing is called, some of you may have heard of it, it's been around for a while now, it's called Hot Science Cool Talks. If you haven't heard of it, hotsciencecooltalks.org, one word, and go to that website. And we've had 138 of them now, and Friday night, 500-seat auditorium, it will fill up very routinely. When we've had some larger name people, we'll go to the Paramount Theater, 1,200 seats, and we'll fill it up. So it's very encouraging. And I invite you to come to one of these events. The next one's going to be on the interpretation of the latest photos that have come back from the Webb telescope, James Webb telescope, which is just mind-blowing resolution of things farther and farther away, so we can get a much better handle now on questions such as the beginning of time and that sort of thing. So in addition to just the talk, it's a 40-minute talk by the speaker, but for an hour and a half beforehand, we have about 10 to 20 tables with hands-on interactive activities related to the topic of the lecture. And so a lot of people say they come just for that as much as anything else. And, as great as we're doing in Austin, I think this is so important. As I said, our attendance is awesome, but compared to that, our reach through the internet, because we post all of these things on the internet, and our reach there is just not quite the same. I would put, have any of you guys been to one of these? No, not familiar with it? I would put the content up against any TED Talk in terms of quality, dynamism, interest, excitement. But TED Talks, since we began ours, we've had over 60,000 views. Sounds like a lot. In half the time, TED Talks has had 2 billion views.
Yeah.
So that ratio of 2 billion divided by 61,000, that's a really large number. So I'm not saying we're trying to compete with TED Talks. It's a totally different model, right? They have a business model. We don't. We're just academics trying to get word out about science. So I'm not saying we want to compete with them. I'm just saying that there's like an appetite for this. So what we've done is teamed up with a filmmaker in the Moody School for Communications at UT, Scott Rice. You may be familiar with him or have heard of his course. It's called Script to Screen. It's also known as the Matthew McConaughey course, because that's one that Matthew shows up at a couple of times this semester, but and it's known as Matthew's course, and Scott's happy with that. Anyway, Scott has worked with us to take some select speakers out of our whole series, like we've taken like a dozen of them now, and made like instead of the hour-long talk, it's now like a 3 to 5 minute, really hard-hitting, really dramatically produced, and the sound, the motion graphics, the cutting, the editing. It's like a short film. And so we are hoping to widen our reach.
Sure.
And I think that what he's produced is great. Now all we're lacking is a way to distribute it. And so that's what we have, people who at the university are trying to help us in that regard. But that's been slower going, I have to say.
Well, we can discuss that offline. We have some ideas about that as well. And of course, we're filming this, and for people who are watching this on YouTube after the fact, there's only about 150 people in this room, but I'm sure that it will reach a larger number of people online, just as your talks do. I'm wondering if maybe we jump into the presentation that you've so lovingly prepared.
Sure.
About Central Texas and Texas's climate challenges that we have in terms of what's going on. So I think Nick's putting that on screen right about now, and you've got your fancy clicker, and I think we can turn our seats around a little bit. You probably know this thing by heart.
Given it a few times.
All right.
But I've specially edited it for today, as you can see on the first slide.
And I should note to the audience, you might have some questions or some points that you want to bring. After we're done going through this PowerPoint discussion, we'll banter back and forth, and we'll talk it out. So Jay, what are we going to talk about here?
Right. So Texas this coming century, the one we're in, human impact on our environment, and really going to focus on climate change and its impacts on things like water, how it produces droughts in the region, how we have to understand the costs of these things in order to make progress. And then also I'll put up an outline. We're also going to talk about pathways to possible solutions. But I guess before we get into this, Lars, I wanted to just say a few words about the film that you guys all watched, which I found really kind of both riveting, jarring at the same time. Not the normal kind of film one watches. I guess no film is normal, but that is definitely outside of 2 Sigma, right, of what a typical film is like. And I was really impressed with it in a lot of ways. One thing you really struck at is the overarching theme, right, this human footprint on the natural system. And one example that they showed, I think, really to great effect is what happens when you build a city, right, and how it just encroaches and overtakes. And for this film, was it 84 that it was made?
Yeah.
I found it to be remarkably prescient in a lot of ways.
Yeah.
Because a lot of things we're facing now, some of the things I'm going to be talking about now, is what is the impact of when we build a city on climate? What is the impact if we build a city on something called the urban heat island effect? What's the impact of when we build a city on water quality?
Sure.
In 1984, these were either unknown, right, in terms of climate change. We had not yet had enough of that Mauna Loa data of the rising CO2 in the atmosphere to be really sure that was anything. It was inklings of it in the scientific community, nothing in the public in that regard in terms of climate change, in terms of the urban heat island effect, and then water quality, impact of cities on water quality. That was also a very nascent field of study. And this film just laid it all out there. Like, this is one of the most critical thing we're facing in our future. So I found it way ahead of its time in that regard.
And we should note, it's a film that is based in a lot of mysticism, Native American spirituality, and having spoken to the filmmaker before, he's a mystic, to say the least. I was sometimes mystified by some of the answers to the questions, but I think in a way that was that he really is going into a lot of sort of spiritual traditions to bring that out. And in a way, I sort of suspected from talking to him that he felt a little sorry that scientists were so slow to pick up on the things that mystics had known for years.
Right, and indeed, and I think something that's become much more widespread now in the scientific community is understanding how we could use our knowledge about environmental science to address this really rapidly growing field of trying to understand environmental justice.
Yeah.
Right, and this goes back to indigenous communities, right? The whole notion of, we're here on this land that others had before us who used it in a very sustainable way, and now we're coming in and using it in an unsustainable way, the way we want, and it's creating huge disparities amongst various underserved, underrepresented groups in terms of who is bearing the brunt of these environmental impacts on a global scale, on a local scale. And in fact, just a few years ago, I started teaching a new course at the university called The Science of Environmental Justice, because there was a lot of student demand for it, right? I think young people today really get it. They want to know about all of this, and they would come into my office. You're the director of the Environmental Science Institute. Why don't we have any courses on this at a university that's supposedly the flagship institution of the state of Texas? So I found that really evocative in watching the film, going back to thinking about, whose land is this, and who gets to decide that we're going to just change it like that.
Who has the right idea about progress?
Right. Yeah. All right. So given that, I do believe, whoops, maybe it's, maybe the reach of it is not far enough.
Oh no. Nick, can you advance us? Are we stuck? Maybe we're stuck. This is a no exit type scenario here. There we are.
Thank you. I guess we'll have to ask you, Nick, to do it each time. I appreciate it.
Or to bring down the other remote.
Yeah, that too. So we'll start out just talking about what does climate science predict will happen with a warming atmosphere. And we'll define this term, the 100th meridian climate boundary, because it runs right through Texas, and it's a very pronounced change in climatic regime. And then we'll talk about past and future climate change, not just today's climate change. And specifically, we'll hone in on impacts on Texas. And wrapping it up, time permitting, we'll talk about potential paths to solutions. And while I don't have anything prepared for reasons for optimism or pessimism, I'm not saying there's no reasons. I'm just saying there's not a slide with it. And
that's your time to shine.
Right. I would rather save it for the discussion if anyone's interested. All right. So what does climate science predict will be consequences of a warming atmosphere? Because we know the evidence has been in for a while, and it's really clear the atmosphere has been warming. It will continue to warm. And all of this comes from these international studies, Intergovernmental Panel on Climate Change, right? We're talking about altogether in these studies, over 1,000 scientists, engineers, technical experts, policy experts getting together. So not yet, but I don't know if it's on a timer or not. And the fourth National Climate Assessment, that was 300 of us. I was one of the co-authors of that 2018 study. So altogether, hundreds, over 1,000 scientists working, and it's often important when you hear a lot of controversy or rhetoric about climate change. Oh, great.
May I see the other clicker?
Yeah, sure. Thanks so much. You often hear, it is working now.
Yeah, it's just
Fixed it.
left window
Okay.
will be most reliable.
So I should point specifically at that window. Okay. Oh, wow. Look at that. Great. Thank you. All right. So as I said, it's often very useful to consider what's known and what is there a consensus of amongst the entire community of experts around the world. Hundreds of over 200 countries participating in these efforts, right? What are the things we know for sure? What are the things over which there's still some uncertainty and controversy? And what are the things that have great uncertainty associated with them? I think it's often important to step back and be able to have a source like this that says, here are the things that are like scientific certainties. So I want to pull out some of the things from these studies and go through these. So if the atmosphere, what will happen is we know the atmosphere will warm. What will happen as a consequence? Well, as we warm the atmosphere, we warm the surface of the oceans. Like any body of water, if you warm it, including a pot on a stove, you warm it, there'll be more evaporations. That'll put more water vapor in the atmosphere. And all other things being equal, that will lead to more intense rain events, tropical storms. By the same token, if we warm the land surface because the atmosphere above it is warming, that will cause more evaporation over land. And in that case, because we have a finite amount of soil moisture, when that gets robbed and that is exhausted, then that could trigger longer and more intense droughts or create droughts that otherwise would not have been created. So, and then the third thing is, as we warm the atmosphere, we will warm the surface of the ocean. Higher sea surface temperatures, that's like the engine room for hurricanes and tropical storms that will make them more intense than they would be otherwise. Right on. So these are three things I will just step back and say they're basically based on the laws of physics and chemistry. And these are things that those laws are things that no one disputes or has an argument about or takes issue with on either side of the debate about global warming. It's often important to step back and say, what are those things that we know for sure?
This is good stuff at Thanksgiving, the Thanksgiving dinner table, too, to know this stuff.
With the recalcitrant Uncle Joe is yeah, my archetype character. All right. So I'd like you now to suspend your attention and just think about what North America might look like from space. And to help you, I'd like to ask you to just close your eyes, lean back, imagine you're in the space shuttle. It's flying upside down. You're looking down at the Earth. Or what was that film with Sandra Bullock where she was an astronaut? She was hanging one arm off of the space. Gravity. Thank you. Yeah, she looked down. And so, what does North America look like if you're up there? If you have a picture in your mind's eye, let me ask you if it looks like this. You can open your eyes now. You guys all conjure up something that looks like this? And I think this is something we all intuitively have in our brains, right? We think about North America or the United States, right? The Southeast is green, lush, humid. Vegetation is very healthy. And as we go across the U.S., driving across I-10, and it becomes arid and not so lush. The vegetation's not doing so well, or it's absent. And there seems to be a prominent boundary, this boundary going right down the middle of North America, and it comes right down through the middle of Texas. And what it shows is that Texas here is actually subject to dramatic climate change as being part of the arid Southwest, which is a very drought-prone part of the world. So Texas is partly there, and Texas is also on the coast of the Gulf of Mexico, which is the source of these tropical hurricanes and storms. So these extremes in the hydrologic cycle, hurricanes and floods, intense rainstorms versus extended droughts, and we seem to be right on the boundary. And where are we in Central Texas? Where are we on here? So here's this little gray blotch on the landscape is Dallas-Fort Worth. Right here, this scar on the landscape is Houston. Yeah, clearly I'm influenced by this movie, right? And this gray blotch is San Antonio. And here's the Balcones Escarpment. It runs through San Antonio, right? So it's the edge of the hill country up to the north, up to Dallas. And here comes the meandering Colorado River. So X marks the spot. If you could see this and this, that X right there is where we are here in Austin. So we could see we're pretty close to this lush, dry boundary or wet, dry boundary. And I'm going to show you some evidence in a minute that boundary has not been stable through time. I'm also going to show you evidence for, or talk a little bit about the history of thought about this. And that's someone who actually coined the term the 100th meridian. Let's talk about that here. Here's the line of 100 degrees west longitude, also known as the 100th meridian. And someone a long time ago, without the aid of this satellite images or going into space and looking back at Earth, was able to be very prescient in terms of recognizing how important this boundary was. And we'll talk about that in a minute. But for now, this 100th meridian, the idea is that this wet, dry boundary has not been stable through time, that it has shifted significantly to the east in times in the past, and by all model projections for the future, will be shifting again to the east. And what will be the consequences of that when it does happen? So I'm going to use the term the 100th meridian. It's not that the line of longitude is moving. That's stuck, right? That's fixed. But we use that 100th meridian as a euphemism for that wet, dry climate boundary. All right, so that's where we're going with this. And we're going to, so there's Austin. And now we'll zoom in on Texas. So here we are at the end of August in the year 2010. And you could see, again, this wet, dry boundary, right? Where it's brown, the vegetation's not happy. Where it's white, the vegetation's absent. Where it's green, the vegetation is healthy. And this is all done with satellite data. Be happy to talk with you about how that's done. But for now, let's take a look. If we go off the eastern edge of the panhandle, that is actually the 100th meridian, right? So let it drop down through here. That's a pretty good call, isn't it, for the wet-dry boundary? It wasn't just rounding things off to the nearest 10 degrees, right? That's a pretty good spatial location for it. All right, so this is the end of August 2010. Now let's roll the clock forward 365 days. We're going to go to the same date, end of August 2011, and let's take a look at that. Wow, right? So I heard audible gasps, and whenever I show this sequence of images in a public setting, there are really loud audible gasps about this. So let's try this again. Okay, yeah, a little better, right? So all kidding aside, right? This was a dramatic shift. This was a start of a major drought, the drought of 2011. It lasted several years, but 2011 in the fall was the most intense part of it. And you could see that wet-dry boundary has shifted dramatically to the east and stayed there for a few years, right? And then more recently, we've been through the summer of 2023, brought extensive drought throughout the region. And there have been significant costs to this in terms of loss of agricultural, loss of livestock, and loss of trees in Texas, which provide a lot of natural capital for us, a lot of ecosystem services that trees provide. Does anybody remember Texas A&M did a study with this 2011 drought? How many trees were lost as a result of it? I'm not counting just the trees and the wildfires and those devastating fires in Bastrop and other places. Most of the trees that were lost were not due to fire. They just didn't get enough water and they died standing. Anybody remember that number? No reason you should. 301 million trees, 10% of all trees in the state. That's a staggering loss of a vital part of our natural world that makes our human world much better to live in. Right, so where'd this idea about the 100th meridian come from? It came from one John Wesley Powell, shown here on the right. And Powell was a professor of geology at Illinois Wesleyan University. But if you went to see him during his office hours, you probably couldn't find him, because most of the time he was out doing field work. He was mapping the western U.S., understanding its water resources, and he did it by horseback. He was the first person to lead a trip by raft for research purposes down the Colorado River. And he developed a really unique high level of understanding about the water resources of the western U.S. And he basically warned that we should not be developing the western half of the U.S. like we have developed the eastern half, unless we were extremely mindful about water resources, because he made public statements to Congress and to others and anyone who would listen along these lines. You're piling up a heritage of conflict over water rights because there's just not enough water to supply the land, right? That was a very prescient statement. He came up with other really imaginative and creative ideas about how to manage water resources, to actually do it by river basin as opposed to state boundaries or international boundaries. He was, in many ways, way ahead of his time. And he did all of this, think about it, without the use of those satellite imagery that we had. Just from being on the ground, he was able to garner this picture. So unfortunately, Powell's voice was not as loud as those of others, and namely the voice that was really loud were those representatives of the major railroad companies. The major railroad companies were during this time of westward ho, expand westward, they were given incredible subsidies for building the railroads, namely hundreds of millions of acres of land in that western U.S. So it was greatly in their interests that that land was being developed, right? And that civilization moved out there because their railroads become all the more valuable for it. So at the end of the day, Powell's voice was not listened to. because of those other influences. But isn't it satisfying? Here we are, what, about 150 years later, that we no longer have to worry about the undue influence of large corporations in terms of how land is used in this country. Powell, is it okay if we go to about 5 o'clock? I have a lot to say about Powell.
We have other films coming in. Well, we have films coming in.
I'm teasing.
Yeah.
What I will quickly say is Powell was ahead of his time and really unique in so many ways. He was an officer in the Civil War and in the Battle of Shiloh, giving the order to his troops to charge. He lost his right arm to musket fire. All right, so they had to amputate it. As you can see, he's missing it there. And so several months later, he gets well enough. Get this, he re-ups his service. And there he is in the siege of Vicksburg, hunkered down in the trenches dug to avoid the musket fire. And like any good geoscientist, he actually studied the strata on the walls of the trenches.
Is there a book about this guy, by the way?
There's a number of books about him, yeah. And I think also he's way ahead of his time in terms of fashion, right? That facial hair outstrips any tech bro I've seen on 6th Street. And I would also say, if you want to know what the next fashion thing is, I would try to round up all pairs of pants you could find on eBay where the belt line is 14 inches above the belly button, because that's going to be the next big thing. Okay, enough with my mild obsession about John Wesley Powell. Let's move on. So the new 100th meridian, right? The idea is, will this boundary shift, right? Here is that climate boundary today. Will it shift? And if it does shift, look what we have lying in wait for it. All of these gray areas are counties with greater than 50% population growth projected by 2050. The state's population will double, the demographers tell us, by about 2060. Where will all these new Texans live? What the demographers project is almost all new Texans will be moving into existing cities, and they will be expanding, right? So this whole corridor here in red, from Rio Grande Valley, San Antonio, San Marcos, Austin, Waco, Dallas, Fort Worth, right? That's lying in wait. So think about what that means in terms of water. If it becomes much more arid because of this shift to the east, then this area that we now live in will have a much lower availability of water. If there's twice as many people, the demand for water will go way up. That is not a way to go about having a resilient future. So is this a recipe for a resilient Texas? I think you could answer that question with resilience defined there. So let's keep this in mind of what is happening now and what will happen in the future as we go forward. So when we look at climate change through time, we talk about present climate. That's the instrumental record. Think instruments like thermometers and rain gauges. And they're good back to about 1900. Before then, the instruments weren't very good. The record keeping wasn't very good. People weren't worried about being nerdy scientists and tracking everything that happens with climate. So back before then, we need a proxy. And so we have a number of proxies we could use. You're probably familiar with things like ice cores. We also use tree rings and speleothems. Those are cave mineral deposits. I'll only have time today to show you a little bit of data about tree rings. And when we talk about future climate, these are model simulations. So these are complex numerical codes run on high-performance supercomputers and research laboratories at universities and government labs around the world. And what they do is they simulate how the atmosphere circulates and how the atmosphere interacts with the ocean surface, how the atmosphere interacts with the land surface. And you could spin these models up and have them run forward into the future, and you could change certain parameters. For example, how much carbon is being emitted to the atmosphere. And we know this pretty well depending on if we are following the way we've always used carbon in the past, fossil fuels. We could project carbon in the future, or maybe we undergo some great innovations, technology, maybe international policy, personal change, where the carbon emissions are much lower. So you could use the models to project outcomes for climate by running the models in like a high carbon emission scenario and say a low carbon emission scenario. And that might be useful to help inform policy in the future. So let me go through some of these really quick here. We'll go through some how we do it in the past, some recent climate, and then what the models show us, and integrate it all together. So to look at past climate, we use tree rings. Many of you are probably familiar with how this works. Yeah, we have the oldest rings in the middle. We could count for the right species year by year and see the youngest rings at the margin. This is just a cartoon. Let me show you some actual data. This is, well, it's actual data. Here we are taking a core out of a bald cypress tree on Onion Creek in Texas. And let's look microscopically at what one of these tree ring sequences look like. So the lower left here is the oldest part of this ring sequence. The upper right is the youngest part of the sequence. I'm going to go through the sequence now, and I want you to tell me to stop when we get to the wettest part of the record. Okay, I calculate 0% participation. So we're going to try it again. Please shout out. I asked Lars beforehand. He said it would be perfectly appropriate if people yelled while we're doing this. So we'll try it again. Try it again. Okay. There. You think this is the wettest part of the record? Okay, that's one vote. Let's keep going. Okay, so there's a vote between here and here. Let's have a runoff election here. How many people say here? That's about 3 people. How many people say here? It's even. It's even. Well, the answer is here, right? The rings are the thickest when the water is most available. When there's a drought and it gets dry, the tree doesn't have enough resources. It has to slow down its growth, so the rings get very skinny. All right, that's how we use this to tell past droughts back in time. So we'll look at some examples of this very soon. But let's first start with recent Texas climate. 2010, 2011, all the way up to 2023. Here's the number of days where it was 100 degrees Fahrenheit or warmer. So 2011, that was that crazy year, right? That's the one I showed you where we had that intense drought for that year and a few years afterwards. 2023 was doing its best to try to set that record. It didn't quite. Let's try another exercise, because you guys were very perceptive in that last one. The human eye and brain are actually very good assimilators and processors of data. So I want to figure out for this 14-year time period shown here, what's the average number of days where you think it was 100 degrees or more? And again, Lars said you could shout out numbers. So it would be a number between 0 and 90 for the average for all those years shown up there. 35, 40, 45, 50. I'm processing all of that. The average of those numbers is actually right around 43. So let's see how you did. What is that average? 44 days. Wow. Even though there was a pretty big standard deviation around your estimates, you guys together collectively hit the average really close. All right, so keep that a number in mind. We're going to use it in a little bit. 44 days where it's 100 or more, right? That feels uncomfortable to me, 44. I know if it's 3 days in a row over 100 and I'm locked up inside my air conditioning, I get kind of grumpy, right? So there are consequences, not just for Jay Banner's self-centered grumpiness, but there's consequences for how the whole world works. And imagine, if you have a job where you're working outside in construction or something like that, you're having to wear a lot of protective gear. That is just a steaming pile of intensity that you're dealing with. So keep that number in mind. We're going to use it soon, 44. So let's look at these model projections really quick. So here are these model projections from that study I mentioned I was one of the co-authors on for the late 21st century. So the last 3 decades this century, this is the estimate that the models, these climate models, project the change in number of 100-degree days. Okay, so we could see right here, this is Texas, all right, Oklahoma and Kansas, and we can see that the warmest colors are like 100-degree days change. So let's go to Central Texas where we are right here. This color is this one. So we're somewhere in the 80s. Let's just say 80. So that means that's the change. So if we want to find out how many 100-degree days there's going to be on average during this time period, we have to add it to how many there are today. So let's use that average, because this is the change, right? It's the increase. So what was the number we have today on average? 44. We add to that 80. That's 124. Help me out, any engineers in the audience? Could you divide 124 by 30? That's around, 4 months. 4 months where it'll be 100 degrees or hotter. 4 freaking months. Think about that.
Starting in May, probably.
Exactly. So they're not going to be consecutive because of the natural variability in weather patterns. There'll be some periods during the summer where it'll be below 100, somewhere it'll be above. So where are we going to fit spread out 4 months of 100-degree days? As early as maybe late April and as late as maybe November. Can you imagine that? Over 100 from April, days over 100 from April to November. What will our world be like at that point? That's just, I think, remarkable and something to really sit back and think about what that will be like. All right, so this is the case of this high carbon emission scenario. Pretty much, we keep using carbon the way we're doing. We say, well, surely we're doing things around that. Well, we're actually really close to this in practice now. But there are ways to project forward, as I said before. What if there were international accords? What if there were, at our own national level, changes in how we emit carbon? What if there was at every state level? What if every household, right? What if there was this collective change in policy, behavior, technology to capture some of that carbon, keep it out of the atmosphere? What if all of these things came through and we had a much lower carbon emission scenario? Let's look at what that would look like. That's this lower carbon emission scenario, and that is a dramatically different world, right? It's still getting warmer, right? We're committed to that because of all the carbon that's already up there. It's not coming out of the atmosphere immediately, so we're already committed to some warming, but this shows a very different outcome, right? A much more manageable, in my view, world for us here in Texas.
Now, is that a radical change in the amount of carbon that's being emitted?
It's a very different trajectory. Yeah, we're basically we have to be off of fossil fuels.
Okay.
Yeah, is what we have to do.
That's radical. I mean, in terms of the political dynamic.
Absolutely. Yeah. And so this brings up an important point. Is this shows I think a couple of important things. One thing it shows is that future climate is dependent on current and future human behavior. Right? There's not anything mysterious about how the world works or anything else, right? It's really dependent on what choices we make collectively, individually.
Jay,
right?
may I ask, is this a sort of fringy kind of activist kind of model that you're sort of bringing up here, where you're sort of picking and choosing this, or is this consensus?
Well, as I said, there's a fourth national climate assessment, right? This is the work of 300 co-authors.
Yeah, just want to hammer that home that this is not some cherry picking, some like doom laden data. This is consensus all the way.
Yeah. I checked my tinfoil hat at the door. Yes. So one important takeaway from this, right? That future climate depends on current and future human behavior, right? And the other thing is we might ask, is there reasons to just give up and say, oh, it's no use, we can't do anything about this. So we might as well enjoy what we have while we're here, while we have it, and don't worry about this. That kind of thinking is actually pretty common, and that kind of thinking is patently unsupported by data like this, because what this says, a good outcome is possible. Now, will it be easy? Well, no one said that. Is it doable? Yes. Will it be challenging? For sure. Do we need to get started now? Yes. All right, so here we are tying it all together. This is the most complicated diagram I'm showing, so walk you through it real quick here. This is the drought record for the 21st century, and going back 1,000 years for the Southwest U.S., including Texas. So it's the year 1000 all the way up to the year 2100, right? This is a drought index on the y-axis, and the cheat sheet is over here. Down is dry, up is wet. Positive numbers means it's wet in the past or the future, and negative numbers means it's dry. Around the zero, a long-term average. So let's look at a few things here. There's brown curve. This is based on the instrumental record, right, for the 20th century. It's when we had the instruments working well. And then it's the proxy record for going back before there. So going back through time, you can see there are some major multi-decadal droughts, right? These are long-scale droughts. And there was here in Texas, this is both the proxy and the instrumental record agree here. This is the 1950s drought, this big dip here. And that was the drought of record in Texas. So we'll come back to that in a second. All these different colors here are now the model projections, show how the models agree with if you run them backward, right? That's an important part of ground truthing the models. But then as they're run forward, you could see this major dive. Different colors are different models. There's 17 different model projections, 17 different labs in the world, and we're looking at their mean and their deviation around the mean. So one thing that's important with these models, they're merely computer simulations. I say merely, I don't do them. The people who do them are really smart and would be insulted if I just was saying they're merely computer simulations. But what I mean merely is every computer simulation, no matter how complex and sophisticated it is ultimately wrong in terms of exactly modeling the chaotic and varied nature of the complex world around us. So we can't just say, well, if the model says it, then that's what's going to happen. And no one who builds or runs these models would ever defend it and say, yeah, this is exactly what's going to happen. But when you look at 17 of them, take the mean, and what they're all showing is this dramatic drop-off in terms of the drought index. It's getting drier and drier. Even given that uncertainty, that's what the gray field is. It's the uncertainty around all the other models, around the mean of the models. By the end of this century, we're in a very different place outside the uncertainty of what's been happening for the last century, right? And the term that's used in some of the articles we publish about this is unprecedented, right? There are unprecedented drought risks for Texas and the Southwest U.S. for this coming century, because it's like nothing we've seen going back in the past, right? So what we're seeing here in 2100, how does it compare? What's the worst thing you see going back through time? It might be this one in the end of the 1200s, might be this one in the middle of the 1100s, and we see that this one caused the collapse of an ancestral civilization in the Four Corners region of the Southwest U.S. And so what price can you put on a civilization being lost? Anthropologists and archaeologists generally agree it was this extended series of droughts over time that made this civilization give up the ghost, as it were. And as we look at what the worst drought is as we go back through time, it's probably this one in terms of magnitude and length in the mid to late 1100s. Let's compare this worst case drought here. And look at that. We're on our way. Already on our way past that. So that's what the unprecedented nature of that term that we use. By 2100, we'll be in places we've never been before.
Let me just quickly put
Please.
my house on the market, if that's okay. I just want to quickly, yeah.
So let's talk about this drought of record here for a little bit. This was a 6-year drought in the 1950s. I don't know if any of you are native Texans or parents were or grandparents were. You may have heard perhaps your grandparents talk about this. This was a pretty tough time. It cost the state a lot economically. It was widespread loss of crops, widespread loss of livestock. A lot of people moved from rural areas to urban areas. That was one of the big beginnings of the shift of people moving into urban areas in the state. And when the drought ended, they didn't just turn around and go back. A lot of them stayed. So it was sort of a permanent shift. It cost us big dollars in terms of our economy, and it's used as the worst case scenario. So there's a state agency called the Texas Water Development Board, you're probably familiar with. Their charge is to make sure there's water for all Texans for all purposes 50 years out into the future. And so what the Water Development Board is it advises water resource managers how to plan. And it says when you're doing your planning for your region, make sure there's enough water for all uses 50 years out into the future should the worst case scenario reoccur. And what's the worst case scenario? It's that 1950s drought. That's what the drought of record means. What's the worst that could happen? Well, what do you think? How is that a conservative way to do planning for the future? If we use this drought, say, versus this drought, that planning ignores the entire proxy record. What that planning also ignores is all of the projections going forward. And so again, pose the question, is this sufficiently planning for resilience on the part of our state? And if you're interested, I could share later afterwards my times at the state legislature testifying on proposed bills to put Texas on the path towards start addressing some of these issues.
I'm going to guess that went great.
It was so much fun. It was. Are there I use the word here, unprecedented. Are there other unprecedented climate events? There's a whole bunch. We don't have time to go into them. A lot of things you guys have probably lived through. But I'll just group them together, these unprecedented events. In other words, worst it was, when these happened, they became the worst that there was before them. So record water shortages, record rainfall, record heat, more intense storms, all right, grouping them all together. How does any of this fit with the predictions of the consequences of a warmer atmosphere? Those were those three things I talked about at the outset, if you remember those. Well, these outcomes are fully consistent with those predictions of climate science. All right, so what will be the costs of impacts on Texas climate change from drought and heat extremes? And how can we best assess these costs? I don't have time. If you guys are interested later, I'll be happy to share with you how we could actually try to monetize what the costs are. And the reason I bring this up is I think it's really important if we're going to get the state legislature and other decision makers to pay attention to realize what we're facing. Often the bottom line, right? How much is this going to cost the state? All of a sudden people pay attention. So I think it's a challenge for economists, for scientists to do this, but it's really essential. And again, I'll be happy to share afterwards during the Q&A if you have questions about that. But for now, to try to wrap this up, what are some paths to solutions? So I've labeled three things here: policies and practices. The policies and practices have to change globally, nationally, state, and local. That's not too big a lift, is it? It's possible. And again, what I just talked about, monetizing these costs. If we don't take any action, a lot of people, let's just wait and see how bad it gets. The difference in costs of fixing things once they get bad, right, undoing the damage, is so much higher than if you are planning and investing now. The investment now is much less expensive than changing things later when they occur.
You sound like my plumber.
Okay, thank you, Lars. The technological advances, yes, we absolutely. It can't be any one magic wand. It has to be across a whole spectrum. And education on personal action, and this goes back to what Lars was asking me about at the beginning, why I've invested so much of my career in terms of engaging the public in science. So I just want to go through a couple of these, two promising examples. One, could we reimagine our cities, and how can we engage communities with STEM? And I won't spend time on the second one because Lars already asked me, and I've already talked about the second one. So let's just talk about reimagining our cities. What do we mean about that by this? So the urban heat island effect, right? What happens is, in the urban heat island effect, is that when we replace a natural landscape with impervious cover, asphalt, rooftops, roadways, sidewalks, those materials absorb and re-radiate the incoming heat from the sun in a much bigger way than the natural landscape does. And therefore, cities are warmer. And the paved parts of cities are warmer than the average city. And it turns out that underrepresented, underserved neighborhoods have more impervious cover of all of these materials I've been talking about than higher socioeconomic neighborhoods. So there's an inherent injustice. And here we are in Northeast Austin Walmart, not too far from here. Just take I-35 up to Runberg Lane exit and make a right, and you'll be at that Walmart. And so what I'm showing you here is this picture. I'm now going to show you an infrared image taken with an infrared camera. And I want you to guess which parts will show the highest temperatures coming off the surface. Which parts of the scene here? You can feel free to shout it out. Asphalt. Really? Not the metal car? Black cars? Okay. Let's take a look. You guys with the asphalt were right. Look at this. 76 degrees, 122 on the asphalt here. And notice the car wheel wells are hottest. You can tell which car parked there most recently because the brake pads were making it very hot in the wheel well area. But anyway, you're right. It's in the shade we're good, and the asphalt we're not. All right, but look at this difference in temperature. How much is that? That's about 40 degrees. Is it not? 40 to 50, 45 degrees, something like that. 45 degrees hotter than it would be otherwise. So now consider this. So now consider those 4 months a year where it's going to be more than 100 degrees here in Austin. You're going to have to add I'll be conservative, just add 30 degrees to it. And you're working a job in construction, roofing, or as a first responder. I have a friend who's just been through the Houston Fire Academy. He showed me his gear that he wears to a call. It's 70 pounds. Imagine that. So it's now 30 degrees hotter than 100 degrees for 4 months out of the year that you're working outside. And I don't think they can work inside, right? They can't, firefighters can't opt to work remotely 3 days a week, right? They're on call and they got to put the gear on. They can't choose not to put the gear on. Oh, it's too hot. I don't want to, right? Just imagine, and that's just those outside jobs. A lot of studies have been done. Be happy to share the info with you. I know I'm getting more and more familiar with it every day. The more I read, it's fascinating and depressing type stuff. But even just in a warmer, slightly warmer environment like in a factory, that worker productivity goes down, even indoors. And so all of these things are going to need to be monetized because they're going to cost our economy as things get warmer and warmer. All right, so reimagining our cities, how do we change this? We have impervious cover, and what are these impacts? Well, there's that urban heat island effect I just mentioned. It just gets hotter when you have impervious cover, but it also has big impacts on water quality and flooding. And for me, again, when I was watching the film, I was really struck, wow, cities just encroaching, taking over the environment. And I immediately went to these things that we have quantified and know, but weren't that well known when that movie was made. Impressive. So I see a great opportunity, right? To undo cities is a hard thing, right? To reclaim the landscape, say all this asphalt, between 6th Street and 24th Street, between Red River and Mopac, all has to change, right? Let's dig it all up and rechange it. I laugh, but it's not funny at all. It's a real huge challenge. But if these cities are going to be expanding because we're going to have twice as many Texans, what an opportunity to get out in front of it, that before these cities are changed, before the natural landscape is changed, before anything is built on it, redesign what they look like. And what do I mean by that? Well, here we are at Jackson Avenue, where it crosses Bull Creek Drive, just west of Mopac. This is a development known as the Grove. I wonder if any of you guys live in the Grove? Okay, good. I'm not going to talk about the Grove. No, not good. This building comes right up to the edge. Here's the street, right? Here's a sidewalk, street, sidewalk, street. I got myself in here one day, and I was almost able to touch. I wanted to see if I could touch that curb and the wall of the building. I could just about do it. What this tells me is that all these new buildings, and I'm not picking on the Grove, right? This has become a kind of a little pet project or pet peeve of mine. Wherever I go all over Austin, the east side, west side, new buildings going up, they're all showing very similar characteristics. The main one that I've taken all these pictures of that shows this is that the built environment is going right up to the curb. There is almost 100% impervious cover being put in what was previously a relatively natural landscape. There was no buildings. It was grass. There was trees. So this is, I see it as a huge, huge opportunity. But interestingly, we're not taking that opportunity. Let me show you, to finish, one example in the past where we took this opportunity. So I think you guys are all familiar with Barton Springs and the relatively natural landscape around it, and the pool, the swimming pool, and Barton Creek flowing down to the Colorado River and downtown Austin. Pretty amazing resource we have. What makes Austin what it is? Since the time of the first indigenous people who had ceremonies there because they felt some really important qualities of spirituality that they got when they were around these springs. And that was thousands of years ago. And now here we are back in the 80s and the 90s. People had a real genuine connection to the springs. And when there's a proposal to develop and put apartments and buildings and impervious cover all over that because it was going to be able to sell some really high-end homes that way, people got up in arms. They were worried about what all that impervious cover addition would do to the water quality of the water coming out of those springs. I could tell you, having studied that water quality, the water quality coming out of Barton Springs is very high quality. You could swim in it, you could kind of ingest it, and the quality is just about near drinking water standards. And as a result, Austin is the envy of just about every city in the world. I would challenge anyone to find a major urban environment like this, where there's natural spring water being issued from an aquifer like this of such high quality. And a lot of this is owed to the effort by citizens as part of the Save Our Springs Alliance and then the ordinance that came out of it. This was a citizen initiative to protect the land. They actually sat in on a city council meeting through the night and through all their efforts and publicity and canvassing and generating support at all levels, was able to actually stop that development. And the development was stopped because the ordinance said you can only have 15% impervious cover on any development of land that you do. That was a landmark case. I'm happy to report here we are over 30 years later, and we can still enjoy really high quality water coming out of the springs. So I put this up here as an example, a shining example of how citizens could get together if they're ticked off and make a change like this. So if we could do that for keeping a lovely swimming hole, which I think is a great thing to do, why can't we do it for mitigating against the really intense climate change impacts that are to come if we continue to develop our watersheds this way?
And that's a great point. And what you say about the Barton Springs, the Save Our Springs initiative, that those were not wild-haired radicals. Those were people's grandmothers, and they were, people's next-door neighbors. And actually, a lot of them looked just like you. In fact, some of them probably were some people in this audience who have been a part of that. So, Jay, I want to thank you so much. And I'm going to call an audible here. We're technically out of time, but I'm going to impose. Let's do 10 minutes of talk back and forth if we can with our audience. I'm sure everyone else here wants to thank you for this incredible presentation that you've just made. So I want to thank you. Thank you. Who has anything they'd like to discuss with Jay Banner? Yeah, I see a hand right over here.
This is a good time with this slide up with Barton Springs and with the Grove. I'm thinking a lot of people, like myself, who were at the Barton Springs all-night meeting and wanted to protect the springs, thought a lot about density, right? Some people might look at that Grove slide that you have and say, well, we're going to build hyper-dense in the middle of the city so that we don't have sprawl beyond where Barton Springs is, so that there's less, or there's more natural area that flows into the springs, and we're going to sacrifice places like the Grove and build denser inside of the city, thinking in an environmental sense. Could you talk about that a little bit?
Yeah, sure, absolutely.
And just for purpose of our camera, they probably didn't hear that. We're going to talk a little bit about the urban planning aspect of one central dense impervious core, which was intended to discourage sprawl.
Right on.
Yeah.
Yeah. Thank you for your question, and thank you for your efforts on Save Our Springs. Good for you. Yeah. So certainly, if we build up instead of out, we do save it. But that's not what's happening in Austin, right? That's not what's happening at all. We may be building up, but we're also building out. So therefore, there is no natural landscape being preserved. So I would say, instead of this, build it even higher and have your footprint on the ground being 1/3 of 100%, 1/4, 1/5 of 100%. And that means you need to build higher. Or, okay, so maybe you can't build higher. Maybe if we had an ordinance that said you have to meet that, the Save Our Springs 15%, great, and you can only go this high because of all the other effects. If you have that many people in that much of an area, then there are other consequences to it that don't make our life very happy. So you might say, well, if you're a developer, you can only build 15% instead of 100%. That means your profits will be greatly reduced. And I would say, yeah, so you're still going to have profits, right? Developers I have no idea off the Grove how much they're making. I know a huge amount is invested to build all of that. I'm guessing no one does that unless they're making hundreds of millions of dollars off of it. and say, well, if they only made, tens of millions of dollars off of it because they scaled it back in order to leave the natural landscape on 4/5 of the land, I would say everybody wins in that case.
And I think too, if Bill Bunch were here, who's part of the Save Our Springs initiative, he would look at that bottom slide and he would say, that's a cool slide. But he says even cooler might be how green it was on the other side, behind the pool. The fact that you kept impervious cover off that land in the distance. So drainage was good, the aquifer was clean.
Absolutely.
Absolutely. Great point. I see a hand right over here.
Just wondering about green roofs, if you do have this urban core that's taken over the impervious cover, what the effect of green roofs is.
Yeah, the green roofs certainly help, but they don't cancel out the effects, right? Because it's just not the same as it being on the ground, right? So while they do help, they can sequester carbon, they can help process rainfall to keep flooding from being worse than if it was just landing on impervious roofs and running off onto the landscape. So they can help in terms of mitigating, but not nearly as good as keeping the land undeveloped.
Does everyone but me here know what a green roof is? Because I really don't know. I'm
sorry.
guessing from context.
All right, yeah, thanks. There could be green roofs, there could be green walls, and it's basically, instead of a roof that's just has, some impervious surface on top of it, like all of our roofs, instead, particularly flat roofs, you could actually plant a forested ecosystem if you had a big enough space, but basically putting vegetation to serve the purpose of both drawing down carbon out of the atmosphere and mitigating all the water that would naturally run off the landscape if it was all impervious cover.
Sure. Yeah, absolutely. Sounds like a cool idea. I mean, not going to solve everything, obviously, but like a cool idea. I see a hand right over here.
Are there forms of asphalts or sidewalks or other impervious surfaces that are better that could, maybe not bring back 100%, but maybe 30%?
Are there forms of land cover that are less impervious, I think?
Yeah, there are pervious pavers. So, right, it's putting down stones that have soil in connection with the ground underneath them, and those could certainly help. And but they won't be the same as if you left the land untouched. So I think for all of these, I don't want to sound like a broken record, but that is sort of my view on this. But to your point, Lars, it's not that there's one single thing that's going to solve this. It's going to take, there's no one silver bullet, right? So it's going to take all that whole list of changing policy at all these levels, technological advances, and then the way we redesign our cities. So certainly that would be a big step forward, but it by itself, right, won't completely fix the problem. Yes.
I think changing the incentive structure economically would go a long way too, but that's a really, really tough uphill battle in our political system.
Right. So how do you do that? The economic incentives, and again, I'm not an economist. I'm not a policy expert. But to me, those are the sorts of things that have to be legislated, right? Like the Save Our Springs ordinance, right? You have to. People won't say, "Oh, it's the right thing to do," or "I need a really big incentive rebate-wise to do it." I think at some point you have to say, "No, these are the limits on how much profit you can make," right? And stick to it. It worked in SOS.
That was a matter of people power too. That was a matter of
Right. So laws are just not going to be passed out of the vapor.
Yeah.
Right. I could share with you that I first testified at the Texas legislature in 2009 on a bill that it was called the Climate Adaptation Bill, right? And the goal was that 14 state agencies would take climate change into account in their planning. And these are state agencies like the Texas Water Development Board, Texas Commission on Environmental Quality, Texas Parks and Wildlife, all of these agencies that you think, oh yeah, part of climate change affects what they do. And so the bill, I was asked to testify on the bill, not for or against it. I was invited to testify on it. And, in 4 minutes, I was told, hey, you've just got 4 minutes. You better say your piece in that amount of time. And I basically showed you a summary of what I talked about here today. So you may be asking, why did I take the better part of an hour if I was able to do it in 4 minutes. And I don't have an answer for you. But at the end of my testimony, someone got up there from a conservative think tank and said that, yeah, God put the earth here for people. He didn't put people here for the earth, right? If you could translate that, what that was, that faith-based argument I found very specious, because although I'm not a Bible scholar, I was able to find on the internet several passages from the Bible that talks about how the Lord wants us to be a responsible steward of what the Lord hath given us. So I find it really jarring and insulting when faith is sort of turned around and used that way. So at the end of the day, the other thing I learned was every bill has to have a fiscal analysis. I should have known that, but a day at the legislature, you learn a lot of things, including how the sausage is made. But every bill has to have a fiscal analysis. And for this bill, the fiscal analysis said no new costs. Because if you propose something, it's going to cost the state $30 million a year, and the money isn't identified, that bill is not going to get anywhere. It's dead on arrival. But this bill was like zero cost. Why? Because all these agencies already have, as part of their charge, their operation, regular planning. And all it was saying is, in your regular planning, make climate change one of those things you take into account. It seemed like the most innocuous first step for Texas to take. And the bill was voted down. Didn't even make it out of committee that year. The ledge met next in 2011, made it out of the committee into the legislature. They never took it up. The session ended, died on the vine. And then every year since 15, 17, 19, 21, 23, the bill with very similar language. Now, different legislators, a lot of the original legislators have since retired. The same bill keeps going forward, keeps getting knocked down. So that's my experience with policymaking. Not very encouraging. But I find that cities, municipalities are a lot more progressive. And there are cities now, every major city in Texas has an office of resilience or an office of sustainability. And they're all looking at the climate model projections and trying to figure out, do we have enough resources? How can we prepare for the future? And how can we do it in a way that we're not going to have underserved neighborhoods bear the brunt of these changes like the urban heat island effect? Sorry, Lars, what were you going to...
No. So we're going to have to wrap it up, I'm afraid, unfortunately, because we have a movie coming in here in 20-some minutes. So I apologize that we have to cut it short. But I want to thank you again so much. Thank you all for being here. And if I may just say, get to know each other. You brought up the name of Bill Bunch, and Bill was one of the first people I ever met when I came to Austin 30 years ago. And these are people like you, people who've decided that they really care about their neighbors, about their world. What you're doing is very important. I appreciate the quixotic idea of even going to the state legislature and trying to do anything. But the fight has to be made, and I totally agree with you. Right. Austin, action in Austin. Action, increasingly people are moving to Manor and Elgin and Buda, and there's no reason that you can't, when you're living in places like that, also be a part of your civic life. We don't have to just assume that everybody there is a Neanderthal. You guys live there too. So I want to thank you so much for being here, and thanks everybody for doing something positive about making things happen. I'm not going to lie, this scared the hell out of me, honestly, and I think that that's about the right thing to happen when we look at this data.
I think it's important to be scared. I'll just say one more thing. I know we have a movie coming in. You might ask, well, is there any reason to be optimistic? I say, I am optimistic. And people say, well, how can you be optimistic? You live and breathe this stuff. You know how bad it could be. And the way I look at it is, right, there's two groups of thought you could have. One is, it's so far gone, it's no use. We can't do anything about it. And in that same group of thought is, it's a hoax, so don't do anything about it, right? All these reasons for not doing anything about it. And then there's other group of thought, other line of thought is, well, with small changes, reasonable actions, we can make a big change for the future. That, if the majority of people in the world adopt that, that is the only way in which it's possible to have a good outcome. Because if the majority of people in the world are in the first boat, it's no use, then we know what the outcome will be. Not a good one, right? Because no action will be taken. So I feel, as a result of that, there's no choice but to be optimistic. Thanks for your time.
Thank you so much.